quantum numbers, right? So what's the importance of, what are the significance of quantum numbers? So first we have four types of quantum numbers: N, L, ML, MS. Simply they have the particular names, but simply you should notice that, or you can able to feed N, L, ML, MS. So these are the helpful one to identify the particular electron place in a particular spherical shape of atom. So that only where we have finding probability of electron, that should be traced by only with the help of this particular four quantum numbers values. Not only to find the orbitals, right? It is also able to calculate the energy. Means what's the energy of electron? That should be also possible by the help of four quantum numbers. So this particular four is helpful to identify the orbitals, right? To identify the electron and calculating of energy. Total number of quantum numbers are four. First one is principal quantum number. Second one is angular quantum number. It is also known as azimuthal quantum number. Angular or azimuthal quantum number. Third one is magnetic quantum number. What we call magnetic quantum number. And last but not least, spin quantum number. Spin quantum number. Especially the spin word is most familiar to the candidates, those who are having a good knowledge in cricket, right? We have pace bowling and spin bowling. So once you have idea about spin, easy to understand the spin quantum number, right? If you have a look, right? Here principal quantum number. So what principal quantum numbers information? So first it is proposed by Bohr, already we discussed. The quantum theory only is designed by a group of scientists. In that, one of the participant, one of the affordable candidate is Bohr. He given information with the quantum number of principal quantum number. Then whatever the principal quantum number is there, it is generally represented with or shows with small n. Small n. Then what information is present? The information from principal quantum number is, it says about size and energy of main shell. This is also we called as orbit or stationary orbit. What will be main shell or orbit? One more. N values is like this: 1, 2, 3, 4. When n value is 1, the name of shell is K. If n value is 2, the name of the shell is L. N value is 3, name of the shell is M. N value is 4, the name of shell is N. Each shell is having its particular number of electrons to hold in particular orbit. So that will be discussed in the next quantum number. About angular quantum number. Angular quantum number. This is also known as azimuthal quantum number. So coming to this particular quantum number, it is proposed by Sommerfeld. Already we discussed Bohr-Sommerfeld model, right, about elliptical one. So here also we call the Sommerfeld, which he is proposed angular quantum number. Then it whatever the quantum number is there, right, it can able to give the information about subshells. Which shell? Subshell. So the information is about only subshells. Already we discussed. Elliptical shape we discussed, no, that we call as subshell. This subshell only we call as orbitals. What we call? Orbitals. We call as orbitals. Then whatever the orbital is there, it is represented with L. L is having a relationship with n, means principal quantum number. L is equal to n minus 1. L is equal to n minus 1. N value started from 1, 2, 3, no? Here L is given the information about shape of orbitals. Shape of orbitals. So what is the shape? So here L values is started from 0 and continued like 1, 2, 3, 4. Because n value is started from 1, 2, 3, no? So what is the relationship? L is equal to n minus 1. If you take n is equal to 1, 1 minus 1, 0. If you take n is equal to 2, 2 minus 1, 1. 1 is there or not? If you take n is equal to 3, 3 minus 1, 2. If you take n is equal to 4, 4 minus 1, 3. So like that we have the values for subshells as L is equal to 0, 1, 2, 3, 4. Then when L value means subshell or orbital value is 0, the name of the subshell is S. If L value is 0, subshell name is S. If L value is 1, the name of the subshell is P. L is equal to 1 means orbital name or name of the orbital is P. If L is equal to 2, name of the orbital is D. L is equal to 3, name of the orbital is F. And L is equal to 4, the name of the orbital is G. Right? These are the informations from angular quantum number. It says the information about subshell. Right? Those subshells are S, P, D, F. We are frequently used in further classes, especially S, P, D, F subshells, or we call as orbitals. S orbital, P orbital, D orbital, F orbital. That is frequently we can able to use in chemical bond as well as coordinates compounds. Right? Just keep it in mind and be perfect with that particular information. You have to get a complete idea with this. We can able to get a good identity and good understanding in further classes, right? So this is about angular quantum number, right? We have discussion about magnetic quantum number, right? Magnetic quantum number is proposed by Landé, right? Then it gives the information about orientation of orbitals, means where orbitals are present, right? On x-axis or y-axis or z-axis, right? Particular exactly that where the direction and place of that particular orbital we call as orientation. Then here magnetic quantum number simply represented with ml. ml is having a principle as ml is equal to 2l plus 1. 2l plus 1 means L value already you are perfect. That is about simply we called azimuthal quantum number, angular quantum number. The values are started from L is equal to 0, 1, 2, 3, 4, what we discussed in the past. Then when you take the m values, the values are minus L, 0, plus L. Means such type of negative values to 0 including the positive values we call as integers. Means always magnetic quantum number values are integers. How it is? Just we have to take with examples. Right? In magnetic quantum numbers, first if you take n is equal to 1, the L value is L is equal to n minus 1, that is the principle to find the L value. Then n value is how much? 1 means 1 minus 1, 0. When n value is 0, the type of orbital is what? S orbital. Then what is the magnetic quantum number value? M is equal to we have principle 2L plus 1. Here L value we have as 0. Substitute in that. Then 2 into 0, 0 plus 1. Then total value is 1. Means when L value is 0, the M value is 1. Means this indicates total values. Total values. How many values are there? Only one value is there. What we discussed? M values are integers. Means M is equal to the value started from minus L, 0, plus L. Right? Then in that the value is what? So we are not having L value as 1, 2 like that. Here L value is 0. Means can we able to write minus 0 plus 0? Only 0 is present. For that, when L value is 0, M value we consider as 0. Means no negative values, no positive values. Further, the type of orbital shape is spherical shape. So spherical shape of appearance is for what? S orbital. Like this we have to find out. So n value is 1 indicates L is equal to 0. The orbital is s orbital. The shape of or orientation of orbital is spherical shape. For whom? S orbital. What is the m value? M value is 0. But don't take m is equal to 1. M is equal to 1 indicates total values of m. Total values how many? 1. In that what is the value? 0 is the value. So m value is 0. Like that we have to write. Understood? If you take n value is 2, the L value is equal to L is equal to n minus 1 means 2 minus 1. Then 2 minus 1 is equal to 1. When L value is 1, the type of orbital is p orbital. Then how to write magnetic quantum numbers? Then m is equal to, we have principle 2l plus 1. L value is how much? 1. Substitute. 2 ones are 2 plus 1. 2 plus 1, 3. Means total values of magnetic quantum numbers is 3. Means 3 orbitals are present. How many 3 orbitals are present? 3 pre-orbitals are present. Because magnetic quantum number indicates the number of orbitals with their shape. Right? Then what is the shape? The shape is dumbbell shape. Right? Already you are familiar. Right? Then how the orbitals are? The orbitals values, m values are minus 1, 0, plus 1. Because m values are integers or not? Minus l to plus l means minus 1, 0, plus 1. If value is minus 1, m is equal to minus 1, the value indicates for px orbital means dumbbell shape on x axis. If you take m value is 0, the dumbbell shape on y axis means py. If you take m value as plus 1, the dumbbell shape on z axis. Like this we have 3 p orbitals. The number of p orbitals are 3. But in simply we can able to express like this. X axis, y axis and z axis. X, y, z. Right? So this particular shapes are very important. Understood? Magnetic quantum number, we have to take one more example, that is n is equal to 3. When n value is 3, the L value is n minus 1, means 3 minus 1 is equal to 2. Means L value 2 indicates d orbital. When d orbital magnetic quantum number, simply 2l plus 1 is the principle. In that L value you should substitute here. The value is 2. Then ultimately your value will become 4. Then 4 plus 1 we have to write as 5. Means total number of m values are 5. Right? It is started from minus l, 0, plus l. Means integers. So the total number of values are minus 2, minus 1, 0, plus 1, plus 2. Moreover, the d orbital shape is double dumbbell. The shape is double dumbbell. Then in the minus 2 m value, that indicates dxy orbital. So it is present on two axes. Whatever the plane is there, xy plane, in that plane we have the double dumbbell of d orbital. If you take minus 1 value of particular orbital, it is yz. This is you consider as y, this is you consider as z. That indicates again yz plane. Then if you take m value is 0, that indicates xz plane. This is x and this is z. Right? This plane means first 3 orbitals are present in a particular their respective planes. But plus 1 means m value is plus 1. Right? That orbital is present on x square y square means exactly on axis. And plus 2 value for dz square, it is having a different identity on z axis. So these are the orientations for each and every orbitals. So that is the specialty of magnetic quantum number, including with the rest of 2 angular quantum number and before that principal quantum number. We have the values or not? Moreover, we given the particular shape or not. So that is the identity of quantum numbers, to know the electron place and calculating of energy. Right? We are discussing about the spin quantum number. So spin quantum number, it is proposed by Gauss-Schmidt and Uhlenbeck. 2 scientists are able to introduce this particular quantum number. Moreover, this it gives the information type of rotation. Means electrons are able to revolve around the nucleus either clockwise or anti-clockwise. So that indicates type of rotation. Then it is represented, this quantum number is represented with ms, means spin quantum number, right? Then if the electron is rotating clockwise, means from like this, right to left hand, so the value of spin is plus half. Same thing, if the electron is taking rotation anti-clockwise, means right to left like this from above the part, that we call as anti-clockwise, the value we have to take it as minus 1. So these are the information about quantum numbers, especially finished with the spin quantum number. This is the very simple one, already we discussed. Spin 1 means clockwise, anti-clockwise. So clockwise is plus value, anti-clockwise is minus value. So clockwise value we have to show like this, and anti-clockwise values we can show like this. So such type of arrow marks we are using in the next topic, that is electronic configuration. Right? Have you got a clarity? Okay children?